Okay, in this video we're going to look in more detail of how to solve exponential and logarithmic equations. We're going to use basically one concept is the definition of logarithm right here. The log of x to base a equals y implies x is equal to a to the y. X of course is positive, a not equal to 1. And then the second concept we're going to be using property of logs. If you have the log of x to base a equal to the log of y to base a, as long as x and y are both positive numbers, then x has to equal to y. So let me just illustrate that with some basic examples. Property A basically states if I have the log of, say, x to base 5 equal to, say, 2, and I want to solve for x. Well, if you want to solve an equation and it's a single logarithm, that's the easiest one to solve, because all you got to do is put it in your exponential form. So from what we'd done before, I know that x has to equal to whatever the base is, which is in this case is 5, taken to the whatever the logarithm is, which is 2. That's an exponent. So x is equal to 25. Okay. Now I can have an equation with two logs and easily solve it if it's in this particular form. So if I have, say, the log of, say, 2x equal to the log of x plus 1. And notice I didn't put a base on the logarithm, so it's understood to be base 10. But in this case it really doesn't matter, because what I have then, I have the log of 2x to base 10 is equal to the log of x plus 1 to base 10. So according to what I have here, the 2x has to equal to what the other expression is on the other side, which is x plus 1. Okay. Add negative x to both sides and I get x equal to 1. Alright, put a 1 there, I get 2, put a 1 here, I get 2. So log of 2 is equal to log of 2. I'm also going to use this property here, as you'll see later on in exponentials, which is coming up next. So let me just clear this. And let's look at the first one. Solve each equation. Okay. So if I have an exponential equation, it's in this particular form. Now if this 3 here had a base or an exponent, a coefficient, I would want to divide through. Okay, so I want it in this particular form, where I just have the exponential by itself equal to some number. Because now I can take the log of both sides, and you can use log to base e or base 10, doesn't matter. I'm going to use base 10, so I'm going to say the log of 3 to the x plus 1 then. That's what this property here is telling me. If I have this works both ways. If I have two positive numbers equal, then I can take the log of both sides, going here from right to left. So here obviously 3 to the x plus 1 is positive, 7 is positive, so I can take the log of both sides. Now it's just a matter of using your properties of logarithms, which we went over last time, and isolating the x, that is solve for x. Okay, so I'm going to write this up here. This exponent here, x plus 1, I can write it as a coefficient, so I'm going to put it up here. So it'd be x plus 1. And that multiplies the log of 3. Okay. And then that's going to equal to the log of 7. Okay, then I can multiply it through here, or I could divide through here if I wanted to. Just divide through by the log of 3. So let's do this. This will be x plus 1 should equal to the log of 7 divided by the log of 3. Okay, so subtract 1 from both sides here, and I'll get x then should equal to the log of 7 divided by the log of 3 minus 1. Now that's your exact answer. Sometimes when you're solving these problems, they'll say give an approximate answer to 2 places or 3 places. Sometimes they will want the exact answer. Well, this is the exact answer. Log of 7 over log of 3 minus 1. Okay. Now if you go ahead and compute this out, use your calculator and take the log of 7 divided by the log of 3 and then subtract 1, then you'll get 0.77. Okay. So down here I wrote it this way. Okay. This is another way. So let me just clear this so you can see it better. Let me clear this. So right here you see the log of 7 minus the log of 3 over the log of 3. This can also be written as the log of 7/3 because I have a difference in log, so this numerator can read it as the log of 7/3 divided by log of 3. So that's give you 0.77 if you use your calculator. So either one of these. This right here would be your exact answer. This log of 7 minus log of 3 over log of 3, or log of 7/3 divided by log of 3. That's your exact answer. The approximate answer 2 places is 0.77. Now, you might say, well, this is not what I had in the previous one that I did. Well, if you divide by the log of 3, you'll get the same thing I had up here, right? Divide by log of 3, I get log of 7 over log of 3, and of course, minus log of 3 divided by log of 3 is minus 1. So it is the same thing, just in a different form. Okay, so your answer to 2 places is 0.77. Okay, now here I'm going to take the log of both sides. Okay, so just to save some time here, that'll be the log here and the log here in front, but the exponent will become a coefficient using the properties of log. So this is going to become this. It'll be the log of 2. And in front of that, the x plus 2 becomes a coefficient. So this will be x plus 2. And the same thing on the other side. I'm taking the log of both sides. And again, you could use base 10 or base natural log or base c. You'll get the same answer. So this is going to come out to the log of 6, because the 2x minus 5 is going to become a coefficient. Okay, so I get this. Okay, so then I'm just going to multiply this out. Multiply by the log of 2, so this will give me x log of 2. And remember the base here is understood to be 10 plus 2. log of 2. And on the other side, multiply through by the log of 6. So this will be 2x log of 6 minus 5 log of 6. Okay, so just using distributive property, multiplying here by log of 2, and then on the right side multiplying by the log of 6. Okay, so this is a 6 here. Okay, now we're just going to collect our like terms, the ones with x's, okay? The ones that have x's to one side, everything else to the other side. So this will give me x, then log of 2. Okay, then I'm going to bring this over to this side, so this will be minus 2x log of 6. And then the terms without an x go to the other side. So this 2 log 2 goes to the other side, so it becomes a minus 2 log of 2. And then I have the minus 5 log of 6. Okay, so what I'm going to do then is here I'm just going to factor in x. I'm going to factor in x out of the terms on the left side, and then the parentheses that will leave me with the log of 2 minus 2 log of 6, and then I'm going to divide both sides by that. So what I'll wind up with is this: x will equal to minus 2 log of 2 minus 5 log of 6. And then that's going to be divided by, okay, in fact, I took out the x, so in the parentheses this left me with the log of 2 here, log of 2 minus 2 log of 6, so this will be divided by the log of 2 minus 2 log of 6. That's the exact answer. If you go ahead and use your calculator and simplify that to 2 places, that comes out to 3.58. Okay, that's what you get for that one, 3.58. Let's clear this. Now on C, I have 5 to the x is equal to negative 3, but see, that's a contradiction. If I were to take the log of both sides, I would get the log of a negative. So log of a negative is not defined. Okay, so 5 to the x has to be positive, because 5 is positive, so any positive number to any power is going to be positive. That can't equal negative, so this has no solution. Okay, no solution. Clear? Okay, so here I had it written out so you can see a little bit better. Minus 5 log of 6 minus 2 log of 2 over log of 2 minus 2 log of 6. Remember, they could be in a different order as long as you have the appropriate sign. Okay, so depending on how you solve it, it could look different. But if you do the calculations, you still get 3.58. Okay, so there's the setup and the final answer. Okay, now the last two are log equations. So again, if you're solving a log equation, the easiest way to solve a log equation is to try to write it with a single log, or you can have it as two logs, but they have to be isolated, one on each side. Okay, so this will, the first one will take care of the first case, so it'll be like this. Okay, so notice I have two logs here, but I have a product. So using your property of logs, if I have a sum of logs, I can write it as a log of a product. So this should be the log of x minus 3, or x minus 5 I should say, times x plus 3. Equal to 2, and the base here is 3. Okay, so that's a single log. Once I have it as a single log, then I can simply go from log form to exponential form. So this would tell me then that x minus 5 times x plus 3 should equal to 3 to the second. Okay, that's just your definition of log, going from log form to exponential form. This is 9. Okay, but then this is going to be a quadratic equation. So this, multiply this out, this will give me x squared, and minus 5x, and a 3x is a minus 2x. Okay, and then 3 times a minus 3 times a minus 5 is minus 15 right here. Okay, doing the full method here, x squared. This is 3 times minus 5 is minus 15, but then I have to bring the 9 over, so this will be minus 24. So that's equal to 0. Okay, it's a nice quadratic, so we factor this into x minus 6 and x plus 4. Okay, so I had factored out, so this would tell me that x then can be either a 6, okay, setting each factor equal to 0 and solving. X can be 6, or it could be negative 4. Okay, but remember that the log of a negative number is not defined. So you have to kind of check these, or at least plug them back into the equation. So if you plug it into the equation where you have the logarithm, and one of them comes out to the log of a negative, that value can't be used. So notice if I put a negative 4 right here, this would be the log of negative 9, not defined. Or if I put it here, negative 4 and 3 is negative 1. The log of a negative is not defined. As long as you get the log of one negative, you don't have to have 2. So this one is not a solution. So the answer to this one then is going to be x equals 6. And they'll check. Notice if I put, well, let me go back to the original equation. You got to go back to the original equation. So let's go to this one. Put a 6 right here where the x is. Log of 1 is 0. So this leaves me then with the log of 6 here, 9. The log of 9 to base 3 equals to 2. Yes, because 3 squared is 9. So it checks. Okay. So that's the way you can check these. Okay, in the next one, I have 3 logs. So the left side is the difference of logs. So I can write that as the log of 3x minus 3 over 4. Notice this is base 10. So this is equal to the log of x plus 1. Okay, so I rewrote the left side as a single log, the log of 3x minus 3 over 4. And the right side I just left it as the log of x plus 1. Now I could bring this log over to this side and write it as a single log, but using the property b that I had up here at the beginning of the lesson, I had the log of this expression equal to the log of this expression. So this quantity has to equal to this quantity over here. This is a 1 there. So I can say that 3x minus 3 over 4 has to equal to x plus 1. Okay, then I just solve for x. So let's multiply both sides of that by 4. So if I multiply the left side by 4, the 4 cancels and I get 3x minus 3. Multiply the right side by 4, I get 4x plus 4. Okay, so now let's collect our x's. So bring this at 4x to this side is minus 3x, and at 3x minus 4x rather than at 3x is minus x. Take the minus 3 over to this side, it's a plus 3, so that gives me 3 and 4 is 7. So I get minus x is equal to 7, so that tells me that x has to equal to, multiplying by negative 1, negative 7. Okay, but you can see easily that if I put negative 7 into this one right here, or this one right over here, I get the log of a negative, so it's not defined. So this one has no solution. I can write the empty set or just say no solution. Okay, we'll continue with another video next time. In the meantime, please subscribe, and we'll check you later.